Hello, welcome to Shrav's technical series. In this series, we are going to discuss Shrav's use case of WebSockets and how to process the WebSockets using C++ Boost ASIO, Boost Beast. And in a subsequent video, we'll discuss how to save the code streams we get from the WebSocket to a Redis time series. So in this video, we will cover only the WebSockets implementation using WebSockets client implementation using Boost ASIO and Boost Beast. So for the demo, we have a service which provides us a code stream. In this case, we have a WebSockets endpoint, which when we send a subscription like this for Ethereum USD prices, we get the codes in this format at a high frequency. So using Boost Beast in C++, WebSockets client, we're going to get this message from the WebSocket and print it to the console. So I'll go through the code. This is the main function. And then we take the arguments, and then we start an IO context. In Boost ASIO and Boost Beast, everything starts with an IO context. That's your class with which you interact with the operating system. So we create an IO context, and then we set a signal handler on the IO context. So on sigint and sigterm, we just stop the IO context. When you stop the IO context, the thread associated with it will stop, and then you'll reach here to the end of the main function. Now we won't discuss the SSL context and all. This is how to set up SSL. This is in the Boost documentation, so you can go through it. Then we create a session which creates the WebSocket, and then it calls the run function on the session, and we pass these parameters. We will discuss that next. And then create a vector of threads, and then we instantiate the threads in this lambda. We pass the IO context which we created out through lambda capture, and then each thread will run the IO context. So that way we have one IO context which had one thread. We added more threads to it, and all these threads will participate in the IO context. And then on sigterm, we come here, and then the threads will join, and then we exit the main function. Now we'll go to the session class. So here we used make shade. Make shade will create a shade pointer of the session. It will instantiate the session and then creates a shade pointer of the session. So it's a handy method to create a shade pointers of a class while we instantiate the classes. And then these are the parameters to the session constructor, and then we call the run function on the session. So let's go to the session definition. Now session implements enable shade from this base class. So this one gives us a handy method called shade from this. So using shade from this, you can create a shade pointer of this pointer of the class. So we'll discuss that where we are going to use it. Then we create a bunch of variables here. We declare them. Then we'll discuss the variables when we use them. Then in the session constructor, we pass the IO context and the SSL context. So we have a resolver which looks at the domain name and returns the IP address. So that's provided by Boost. Then we have the WebSocket. We create a WebSocket variable here. We created a WebSocket variable here, and then through initialization list, we create an instance of WebSocket. We'll discuss what main strand means. We can discuss make strand here. Make strand is a concept in ASIO through which only single thread will create, single thread will run this one. So we'll discuss the actual usage later. So the WebSocket is created here. Then we pass the IOC reference to the IO context. Then we create a strand. Now a strand is a concept in ASIO through which when you submit work to a strand, the strand will ensure only single thread would be running at a time. In a multi-threaded environment, if you create a strand, the strand is only executed at a time by only single thread. So this way you can avoid mutexes. It's more like a lock-free way of implementing the code. So we'll discuss more when we see the usage of make WS strand. So we have the run function. The run function will resolve the host name, and then there's a concept called bind front handler. Bind front handler will return a functor, a function object. So the bind front handler will take the shade pointer of this, so session this pointer, and we pass the reference to the onResolve method. So the bind front handler will use this pointer, shade pointer of this, and resolves the onResolve method on this pointer and creates a new handler, and that handler is nothing but a function, and that function is called after the resolve completes. And when resolve completes, it will pass the required parameters to onResolve, which are these two. So you could think of this as an event handler or a completion handler. So when async resolve completes, it ensures this method is called. So on resolve we get these two parameters, and then here in get lowest layer is a method in Boost through which we can get the underlying socket. So for example, here if you see you have WebSockets, then you define WebSocket as and implement in this template format. So the lowest layer would be WebSockets Beast TCP stream. So you get the Beast TCP stream is the get lowest layer. On that, which is a socket, you set the expiration time. Similarly, get lowest layer will give you the WebSocket on which you set the you do the async connect, and then again use the bind executor, and then you do the same bind front handler. Here you use the WebSocket strand. Now, as I mentioned before, a strand will ensure that that function is called by a thread only once, so no other thread would be calling the same function. So that way, if you have any shared memory or data which can be corrupted, it's a lock-free way of ensuring that that function is called only once by a single thread. So in this case, we add a bind handler because on connect we are accessing the WebSocket and its underlying socket. So we don't want two threads accessing the socket at the same time. Even the WebSocket and sockets are not thread safe. So if you define a strand here, only a single thread will call on connect. So we do the on connect, get lowest layer, we set expiration time and all, we do SSL connect. Once the SSL connect is complete, we call this handler, and in this handler we again do the WebSocket connection, and once the WebSocket connection is done, on handshake complete, we do the first write. We do the first write to the WebSocket. In our demo we were writing this one. So we send that message, and then once the on write is complete, again we use a strand so that only a single thread would run it. We come back to here, and then we ignore it, passes on write passes error code and bytes transferred. We ignore the bytes transferred, so that the compiler warnings are suppressed, and then we read on the WebSocket. So since you have written to the WebSocket, you should be getting this information on the WebSocket. So we read into this buffer on the WebSocket, and then again we use a strand to call the onRead. And onRead, we get the information on the buffer, so we print out the information, and then we empty out the buffer, and we call the buffer again, and we call the async read on that buffer again. So we give onRead again as the completion handler. So this function will go in a loop, and as you can see here, we get multiple messages. So each message will be picked up in a loop. So the IO context, all the threads will be active in this function. And when they call in series, so if you see here, these are the messages we got from the WebSocket. So yeah, multiple threads are actually calling here. If you see them, they all printed by different threads. So I have 3 threads printing the messages. And that's it. And this on close will close the WebSocket. Thank you for watching.